Hi everyone, welcome to part one of a series of tutorials around demystifying coding slash an introduction to object-oriented programming and getting into actually writing a bit of JavaScript for some of our projects that we're working on in our course. So before we jump into things, just a bit of a TLDR for this series, that this is just a TLDR when it comes to programming. We're really, the intent here is to help you build coding literacy skills, focus on demystifying programming, object-oriented programming concepts in particular, so you're equipped with enough of an understanding of these concepts to be able to read code yourself, understand what you're looking at, and ideally build on top of that for your own projects. So to begin with, we are talking about programming languages, and the first thing to know about programming languages is that they are just a language. So similar to written or spoken languages, they consist of various components, each with their own specific purpose or function. So, if we look at something like the English language, for example, we can break it down into nouns, right? People, places, or things. Adjectives, these are things that describe our nouns. Right? Verbs around for expressing an action or state. And things like adverbs for modifying or describing particular verbs or adjectives. We need to be a little more specific. So what's common across object-oriented programming languages is that they have similar analogs to nouns, adjectives, verbs, and adverbs. They just have different names, and it's likely that you've heard these names thrown around in one way or another. But really, if we think about programming language as a language, we're really just dealing with the same parts of any other language. So when we're talking about our nouns when we're programming, so our objects, these are often referred to as classes, or sometimes just objects themselves. These are the things that we're working with. Um, if we look for an analog with things like adjectives, things that describe a noun or an object, these are pretty much what's known as our fields. So classes have fields which describe them, and then our analog to verbs are what we call our methods. So methods are things that express an action or state of a class. So we can think about these as the parts that are doing something. Um, and then lastly, our adverbs, we call those parameters. So these are things that modify or describe a method or a field. So, I mean, these are really the building blocks of any programming language. And just like a written or spoken language, there's different varieties of each type, and we can combine them in different ways following a certain syntax in order to communicate, in order to write messages or commands that can be interpreted and understood elsewhere. So we're going to carry through this metaphor of nouns, adjectives, verbs, and adverbs in our introduction to object-oriented programming. So, I mean, really the object in object-oriented programming is our classes. It's our objects. And there's a lot more which defines an object-oriented program. But one concept we're really going to pick apart today, and I think is the most important takeaway from this, is this idea of encapsulation. So encapsulation, I mean, it's really just a fancy way of saying that the objects we're talking about, our classes, they contain all the data about themselves. So in other words, the things that describe themselves, or the fields, as well as all the things that they can do, or the methods. So whatever language we're talking about, and examples of object-oriented programming languages are things like C#, Python. We'll be dealing with JavaScript in this class, which is arguably one of the more kind of complex languages, or ones that kind of deviate from this nice clean pattern of classes, fields, and methods. But the concepts are pretty much the same, right? So the idea is that we have these objects or classes, and everything about these objects is contained within them. So what does that mean? Let's look at an example here. So rather than jumping in and writing code right away, let's break down our classes, fields, methods, and parameters in a scenario that may be a little more familiar with us. So I mean, let's look again at the English language and think about just a noun or an object that we may be writing about or talking about. Something like a dog, right? A dog is a noun. So if we're looking at programming, we can think of this dog as our class. So typically we see classes denoted like this. So again, like syntax is going to vary from language to language, but typically you'll start to see the same patterns again and again, where we have a definition of our class. We've named it something, dog, capital D. And then we've got these brackets here, and this is what's really going to allow us to encapsulate information or data about our dog class. So at a bare minimum, we've got our class, dog, some brackets, but nothing inside of it right now. So if we want to describe our dog, we might want to create some fields or populate some fields about this class. So if we look at our dog class here, within the brackets, we might encapsulate some fields or descriptions of our dog. And these could be something like the color of the dog, the size of the dog, is the dog a good boy, which should always be set to true. And along with this, we might be able to describe certain actions that our dogs can do. They can do things like bark, and they can do things like roll over. And these actions are what we call our methods. So again, we've got our dog class, our object, and then encapsulated within our dog object, we have fields describing it, and we have methods describing actions it can do. So notice another common notation we see here that distinguishes fields from methods is that methods tend to have these parentheses, other brackets, next to them, which typically indicates that they are a method. So if we break down that method in a bit more detail, so I'll go back here. I've noticed I have two methods, bark and roll over. These themselves, our methods, can contain information or encapsulate information within them. So we can kind of think of these as objects in themselves. So again here we have a definition for what our rollover action actually does. So here again, starting at the top, we've got a name for our method. Those parentheses let us know it's a method. And now these, again, open and close brackets. And here we can actually describe the logic around what this action or method does. So if we kind of break down the action of rolling over, well, maybe we can follow these steps. Our dog can lie down. The dog can lean to the left and maybe keep leaning while paws are off the ground, and then just keep holding that position until finally their paws are back on the ground, and then we stop. And this is really our the logic we're writing now. And notice that our methods can actually contain other methods. So here, we're just describing very granularly what rolling over should be. But we also start with this statement to say lie down, and again, with these parentheses, indicating that this is another method or another function. So this might be defined elsewhere. But the idea is that we could reuse these methods or functions again and again rather than rewriting this logic over and over again. So hopefully that wasn't too complicated. To complicate things, though, a little bit further, is the way we've written things here. Our methods are actions, but when they're not contained within our class, we call them a function. Essentially, they are the same thing. They are describing an action. The only difference is the way I've written it here. It's not encapsulated in our class. It's just outside of it right now. Just something to know. You'll often hear functions and methods used interchangeably. The only difference is when a method is defined within a class or an object, where a function exists on its own. So here's an example. So again, to go back here, we've got our dog class with fields describing it, methods describing actions it can do, and those actions can be broken down into more granular steps that are executed when the method is called from our code. So now we can add a bit more information to our actions here. So, and this is where these little parentheses come in handy for um, our methods we've created here. So notice when we wrote this rollover, we started with these parentheses, nothing was inside of it. Um, what those are meant for is for accepting or defining parameters. So again, like a parameter is the equivalent of our adverbs, so they provide a bit more information about the action itself or the object itself. So whereas our first definition of our rollover method, we said lie down, lean to the left, keep leaning while paws are off the ground, then stop leaning once the paws are back on the ground. Well, maybe we want to add a bit of variation or the ability to tailor or customize this method or action in a bit. So here we've sort of hard-coded into our method definition that rolling over means you should lie down and lean to the left, but our dogs could lean in different directions. So here's where we could define a parameter for our method, saying, when we call this rollover method, we're going to give our developer the option to specify which direction they're going to roll over in. So here we can say rollover accept a certain direction. The rest of the command is pretty much the same, lie down, but now we're going to say instead of lean to the left, lean to whatever direction was passed to our direction parameter, often called our argument, and then execute the rest of the command as expected. So that's essentially the basics of the parts of a class and what constitutes our fields and what constitutes our methods. Let's look at another example of being able to write some of these commands. So in general, when you're actually writing your code yourself, there's a common syntax to follow is you first type or call the class itself, so the object you want to interact with. You type a period, and then that will give you access to what's contained within that class. So you can do things like type the name of a class, dot the name of a field, and that will allow you to access information about the objects by reading its fields. So we can also do this. This is also helpful when we actually want to write values to these fields. So rather you can read them or you can write them depending on what the field is. And then when it comes to actually executing or calling methods, it's a similar type of syntax. So we first say, which object we want to use, period, and then we can access what's encapsulated within inside of it. In this case, we can call the method. So method by name, then we have parentheses, and then we specify arguments. So, and arguments are just the actual values we are passing to the parameters of a method. So if I were to go back here, we've defined this parameter called direction, but when we actually write the command itself, we might say left or right, and that's what we consider our arguments. Okay, so let's do some examples of actually writing these commands now. So let's start with the English language, and let's say, think about a command we might be giving our dog. So if we were just speaking English or writing English, we might say, hey doggo, roll over to the left. If we were going to give the same command using some sort of object-oriented programming language, again, we would just sort of translate this using the components that we know of, classes, fields, methods, and parameters, and the syntax that we learned about earlier. So calling a class name, dot field or method, and so on and so on. So let's go through this. So let's rewrite this in code. So the first thing we would do is actually define a variable and assign that to our dog class. So here we've got something called doggo. We would first want to define a new instance of this class. So we could say something like our variable doggo, or we can name it whatever we want, equals a new dog. So we now have a dog. From there, we would point to our object, which is our doggo, dot, call a method within it, roll over, and then pass our parameter to the left. And then finally, something I didn't talk about is we would want to end our line, so end our command. So just like in the English language, we end our sentences with a period. In most object-oriented programming, there is some way to end a line of code, whether that's typically a semicolon. Sometimes it's things like line breaks or other carriage returns as well, but it depends on which language you're working with. Okay, so we can go beyond this as well. So if we really wanted to maybe provide more complex commands, we could bring in something like a conditional. So a conditional statement will allow us to execute certain lines of code if certain conditions are met, and other lines of code if other conditions are met. So, and again here, the syntax is and the rules we're following for accessing the parts of objects, their fields, and the methods pretty much stays the same. So here, we may say, okay, our doggo, we can give him this command, but maybe he's only going to follow our commands if he is in fact a good boy. So our conditional statement at top here is we can say something like if, and then within the brackets we state our condition. So here we're going to read our field. If doggo dot is a good boy equals, and always equals true, then we're going to create some open brackets here and say, well, what will our doggo do? In this case, we're going to just carry through the command we created. Doggo dot roll over to the left. And then we can build on top of this to create other conditions where, say, if our doggo is not a good boy, or if this condition is not met, we can use this else statement to say, well, maybe we're going to execute some different behavior. So if our doggo is a good boy, roll over to the left. If he's not, then doggo will, we're going to call a different method here. We're going to say that doggo will bark and pass an argument adorably. So here we can start defining more complex behavior, but what I'm hoping you're seeing is that really the building blocks are the same. We're still just dealing with nouns, verbs, and adjectives and adverbs here, but in just the case of programming, they're just called classes, fields, methods, and parameters. That's about the basics of object-oriented programming. This can be applied to C#, JavaScript, Python, and the syntax is typically the same. Things will change from place to place. Things like Python will rely on indentation. Some of the details will differ. Just like if you look at different languages, syntax and some of the characters will change. But typically the components, everything still consists of nouns, verbs, adjectives, adverbs, right? These parts with their specific roles and duties stay the same regardless of the language. Okay, so that's kind of as much theory as we're going to do on programming and object-oriented programming. So what we're going to do next is go into a example of how we might use JavaScript along with the HTML and CSS we've already learned in class to build a bit of interactivity into sites we might be building. So for the next part of this demo, I'll be using a repository that I've created in our class's public repo, just called JavaScript demo. So if you're going to be following along yourself, something to know is that what's a little bit different about this repository is that I've created different branches for you to use. So if you actually come into the project within Bitbucket and you go to this little drop down here, by default, it's always on a master branch. But for this, I've created a final branch and a start branch for you to look at. The idea being here that this is pretty much the same working files at different points in the development. So the start uh, branch just contains an index.html file and a CSS file with some basic styles created here. And surprise, surprise, this is the starting point for the demo. And if you want to jump ahead and see the final version of it, you can change branches and go to final. If you want to follow along and build with me as I'm going through this demo, you want to select the start branch, and then you can clone this to your computer via source tree, or just download it directly. Okay, so I've already got these files. Let me close this. If I go into Visual Studio Code and I open up the files I put in that repository, you'll see, again, as I said, we've got our index.html file. We have a CSS folder with our style sheet. Here I've only defined a single class called modal. In our index file, there's not much there except our head. We've already linked our style sheet. And then within our body, I have a single div, which I've given the ID label. And a class, I've assigned that modal to. So if we actually open that up and take a look at it, just refresh, you should see something looks like this. Right. So I've got my this is my single div. I can inspect it if I want to. Right, with that modal class applied to it and an ID that I've called just label. It's just containing text that says lorem ipsum right now. So I mean, this should be old news for us. We're just using our HTML markup language to define this element, and then using CSS to style it. So now the question may be, well, what if we want to add a bit of interactivity to this? So the job of interactivity, if we go back to thinking about the separation of concerns, should really be handled by JavaScript when we're talking about web-based experiences. There's other ways to make this interactive. We can embed things within the HTML itself, even do things with we can get fancy with CSS, but to keep things nice and separated and organized, it's always good to reserve interactivity to be handled by JavaScript, by some kind of programming language. So let's look at how we might actually go about doing that. Okay, so the first thing I'm going to do is, similar to the way we created a separate CSS file and linked it to our HTML document, we can do something similar with JavaScript files. So I mean, there are ways to write JavaScript directly in your HTML document, just like there are ways to write CSS directly in it and style it. But again, for keeping things organized and keeping things separated, we're going to build it into a different file. So in Visual Studio Code, first thing I'm going to do is create another folder, which I'm going to call JS to house my JavaScript. And within that, I'm going to create an empty file called script.js. And you can see automatically it shows up in my window here, and it's completely empty. And there's nothing here. So similar to the way we link to style sheets when we want to apply our CSS to HTML elements, we are going to connect our HTML file to that JavaScript folder, or to that file. We do it a little bit differently. So the way we're actually going to do this is actually go right into the body of our HTML document, and we are going to make use of the script tag. And we're going to define a source for this. So, source might seem a little similar to you when we do things like use the image tags or video tags. We're also defining a source to pull into our document. This is no different. So we are actually, rather than pulling in an image or pulling in a video into our file, we are pulling in a JavaScript file. Notice Visual Studio Code does some nice autocomplete for me, so I don't make sure I don't spell anything wrong. And just like any other HTML element, I want to close that tag. So essentially what this is doing is pulling the contents of that script.js file directly into the body of my HTML document. I can hit save. If I go back to my page, surprise, surprise, nothing's happening. So that script tag doesn't actually get rendered in any way. It's there, but it's invisible to most of the users. Okay, so now what we can do is actually start writing some JavaScript. Um, and so I'm going to go back into my JavaScript file here. So the way JavaScript works is by interacting with something that's known as the document object model, or the DOM, of a site. Now, the document object model of a website is really spelled out really well in your HTML file here. So, when we were writing HTML, we weren't really coding anything, we weren't programming anything, we weren't defining any logic, we were defining the structure of our website, and we did that through our HTML tags. This is another way of interacting with the DOM, or document object model, where we're actually defining the objects in our document. So here we're saying our document consists of a large HTML element, our head, our body element we can think of that as an object. Within that object, there are other objects like this div and our script, and so on and so on. So whereas HTML defines what the objects are in our document, JavaScript interacts with the DOM and allows us to actually do something with those objects. So the first step is usually finding a way to find out what those objects are, and actually get them, and perhaps save them in a variable, and then we can start writing some code to interact with them. So typically, in order to get a hold of these objects, we can leverage things like the IDs of elements. We can leverage things like the class names of these elements. In a similar way, we use CSS and CSS selectors to access parts of the HTML element and the DOM. We can do the same with JavaScript. It's just done in a different way. So if I go back to my HTML file here, and I go back to this one div that I've created, this object, you can see that I've given it the ID label. So IDs are unique and specific to single HTML elements. So this is a great way for me to specify this specific div in my JavaScript. And to do that, I'm going to be writing some code. So one way to do that is to use what's known as the document class, and then within that we have a method called get element by, and you can see what's nice in Visual Studio Code, these start auto-completing, so you can see kind of all the different ways you can get elements in your document. You can do it by ID, as I have here. You could also get elements, plural, by their class names, by just their names, tag names, and so on and so on, or even get selection, so user-generated input here. But I'm going to go with get element by ID. So my class is my document. I'm going to call the method get element by ID, and here I'm going to pass an argument, which is going to be the name of that element. And then I'm going to finish my line with a semicolon. So this is the kind of the basics of JavaScript, and the basic way we first start interacting with the parts of our HTML site. I'm going to go a step further here, and rather than just constantly calling this class and this method again and again, because I want to do a few things with that object, I'm going to save this to a variable. And there's different ways to define variables in JavaScript. I'm going to define a constant, which just means that this variable is never going to change. I'm going to assign it a value, and it's going to stay that value throughout everything else I'm going to be doing. So I can come up with my own name for this variable and set it to equals. So now I'm going to have this variable constant myLabel, which this could be anything we want, right? We can call this doggo if we really wanted to. It makes no difference. I'm going to call this my label, just so it makes sense as I'm writing the rest of my code. I'm going to say this is equal to what's in my document and an element within my document with the ID of the name label, and that should be set. So that should get that object for me. I can hit save. If I go back to my page, refresh, nothing happens. Surprise, surprise. All I've done is just access that element within my HTML site, but I haven't actually done anything to it. So what I can do now is, now that I've defined that object, so my label is now an object, I can start changing fields on it, or I can start calling other methods on this object. Again, I can access that just by typing a period. So here right away, I can see all the different things I can do with my object, and there's lots and lots of stuff. The thing I'm going to do is that, since this is just containing text right now, I can scroll all the way down, or I can just type text content. So you can see that this is a property, which is similar to a field, except a property, its value can be changed, whereas fields are typically things that you're just reading the value of. So here I'm going to say mylabel.textContent equals, and I'm going to set that to some value. Hello there. And then again, end my line with a semicolon. Now if I hit save and I go back to my site and I refresh it, you can see that now I'm actually interfacing with my DOM. I'm actually changing the contents of these objects from these commands that I'm writing in JavaScript. So from here you can see, not much is happening. I can click on this, I can roll over it, nothing is really changing. I've essentially just changed the content of that div. If I go back to my code and change it to something else, add an exclamation point, smiley face, hit save, that gets updated when I refresh. That's the basics of interacting with the DOM and accessing elements in our site, and then being able to change things like properties on them. But we probably want to start building not just ways to change the content, but means for users to provide input, and then maybe then changing our site and providing relevant output and feedback. So the way this is typically done with JavaScript is by using things called event listeners. So now that we've been able to access the parts of our site, we can do things like add event listeners to them to wait for and read actions that the user might be taking when they're, or interactions they might be having with those elements. So let's do an example here of what could happen if a user clicks on our object. Okay, so to create event listers, again, we're going to follow the same sort of syntax we've been following all along. I'm going to get my object, which is called myLabel, and call a method, which is add event listener, and then pass arguments. So for here, we can listen for different types of events that are happening on our HTML objects. There are some pre-built events that we can call just by specifying their name. So if I put in quotes here, you can see right away I can listen for different things that might be happening, whether they are things being dragged, things being double-clicked, things coming in focus. I'm going to just listen for a click. And then this event listener method actually accepts two different arguments. I would specify two parameters. So first, which event we're listening for, and then the second, what we're actually going to do when that event happens. So here we actually want to describe an action, something to happen. And this means that we need to define a function or an action to happen. So to do that in JavaScript, we just write function. We add our parentheses. Right? We're not going to be passing any parameters to this. So here we're actually defining a function, and I'm going to use my curly brackets to say what the logic of that function is. I'm going to hit enter to just sort of open that up a little bit. But again, to reiterate what's happening here, we're calling myLabel, adding a listener to it, listen for a click, and when that click happens, we are going to define a function for it to execute. So here, I'm going to start writing my command. So again, I'm going to say maybe myLabel dot text content, and then rather than saying hello there, I'm going to say General Kenobi. And I will end my line here. So I will save this. Let's go back to my page now. If I refresh it, see it says hello there. So following along in my script, my JavaScript is telling it, okay, change the text content to say hello there. And then when I click on it, listen for that click. And now when that happens, change the text content to say something else. So let's see if that's actually happening here. It says hello there. I click on it, and the text is updated. You can see. So here we've got the basics of now being able to access parts of the DOM by assigning HTML elements to our variables. We can change the properties of those HTML elements, and now we can start building interactivity by listening to those events that may happen on them and then executing functions or actions. So you might start looking at this and having a bit of trouble discerning like what is what as you're looking at this. It's a bit hard to see. So what we can actually do is, if we find that we're going to be reusing these functions, or we just want things to be a little more organized, we could define these functions anywhere. So actually, I'm going to take my code here that I've got, definition of my function, and I'm going to remove it from here. Right, so notice that that's the same line I had, I'm just not passing that second argument. And I'm going to move my function down below. You see I get a bit of an error here, but what I can do is give that function a name. So I'm just going to call this my function. And now, rather than kind of rewriting this function every single time I want a click to happen, I can just call my function instead. So look at that, it's a little bit cleaner, it's a little bit easier to see now. So when this label, we're going to add a listener to it. When a click happens, we're going to call my function, and what my function does is change the text. So I'll save that, go back, refresh this, still says hello there. I will click on that, and it still works fine, General Kenobi. All right, so right now we've looked at how we can get our JavaScript talking to our HTML or HTML talking to JavaScript. To really start building some really neat and powerful interactions, we need to go a step further and start seeing, well, how can we access our DOM elements through JavaScript, but also do things like change the styling of our page or how things look by accessing CSS. So let's kind of continue to build on this example we have here, where we click on an object, we can tell when that click happens, and then we can execute a function when that event is triggered. Our functions don't have to just do one thing; they can do as many things as we want, as few things as we want. And what I'm going to do now is change this function so it actually changes some of the CSS on this element. So first thing I'm going to do is actually go back into my styles. Here I've got a modal class. I'm going to create one more class. I'm going to just call this, let's make up a name for it, sample class. And I'm going to, actually I'll just call it sample. And I'm going to just define something like, let's set the color to something random here. Let's just scroll down. I'm going to say crimson, and then save. So here I've defined a new class. If I look at my HTML, only the modal class is applied to my div right now. But I can use JavaScript to change that. So here I'm going to say, okay, when this function executes, let's still change the text, but I'm going to change some more things about my label. And one thing I can do is access a list of classes on this label, and I can call a method on this known as add. So this will allow me to add a class to the list of classes that are already on this object known as my label. So what I'm going to do is just call the name of the class that I created called sample in my line, hit save, and now let's see what happens. I'll go back to my page, hit refresh. I will click on this. You can see not only did the text change from hello there to General Kenobi, the color change as well. And if I inspect this, you will see that on the client side, let me open this up. If I look at this div, it still has my ID of label, still has the modal class, but that sample class has also been added. So now I can start building really powerful interactions where I can respond to user input and actually change how my site looks and feels. So from here I can keep building on these interactions I've made by creating new event listeners for looking for different types of input users might be executing, as well as by creating new functions to specify new actions or different tasks that might be executed based on that input. So let's walk through an example of that. So here I've got an event listener for what happens when a user clicks on an object, but I think I want to do something like add hover states to this particular element, or do something when a user rolls over this element so they know they can interact with it, build an affordance like that. So I'm going to create two new functions that I can call. My first one's going to be called onInter. And again, I'll define it by calling function. I'm going to name it, parentheses, and then brackets. And I think I'm actually going to use this line of code here where I'm going to add a class to the object when I mouse over it. And then I'm going to have another function for when the user hovers off of that. In here, I'm going to say my label, again, access the class list, but this time I'm going to call remove. So when I do this, I'm going to call the same class, but rather than adding it, I'm going to remove it so it goes back to normal. So I've got these functions, onInter, onExit. Now I need to create event listeners to actually trigger them. So I'm going to follow the same pattern I used earlier. I'm going to add an event listener. Rather than a click, I'm going to use what's first one is going to be called mouse enter. So mouse enter gets called when the user's mouse enters that HTML element, and rather than calling my function or something else, I'm going to call the function I've already defined on enter. And I'm also going to add an event listener to listen for when the mouse leaves, and I'm going to call instead the onExit function. All right, so here I've got three event listeners defined, one for when I click on my object, one for when I just the mouse enters the object, and one for when the mouse exits. And again, I'll be calling three separate functions depending on which event gets triggered. So let's see what happens here. Now you can see I'm not clicking. If I just mouse in, you can see that class is being added, so the color is changing, and when I mouse out, that class is being removed, going back to normal. If I actually inspect this, I can see those changes happen in real time. So you see that sample class being added, that sample class being removed, and if I click on it, you see the actual text content being updated. So we can do this with any HTML element as long as we have some sort of ID or some information that we can interact with via the DOM. So that includes divs like this. It also includes images and also SVG files. So I'm going to walk through an example of setting up similar event listeners and functions to execute, but now working on an SVG instead of a div. So if I go back into Figma, I've actually created a file with this face, just to, sorry, let me make this a little bit smaller. So here I've created just a illustration in Figma. You can see it's just made up of a few different vectors. I've named each one of my layers here with a different name here. And what I'm actually going to do is export this file. So if I actually go into my inspector in Figma and scroll all the way down, there is an export option. If I click on the plus, I can export this, whatever I've made and selected in Figma. I've got a few options, so by default it's a PNG, but here I actually want an SVG, so a scalable vector graphic that I can use on my website. If I select that, you'll also see there are some options in this little overflow menu for export settings. So I will export the contents only, so I don't want anything in the background. But what's really powerful in Figma is that we have the option here to include an ID attribute, which means that for every single layer I create in Figma here, whatever I've named it will be automatically assigned as the ID name for these HTML elements. So I'm going to enable this, and I'm going to click Export. And just for the sake of what we're doing now, I'm going to actually just save this in my in our working folder here, so you can have access to it. I'm just going to make an images folder here. Not actually going to be accessing this directly, but you'll be able to see it. So if I save that, it's been exported. I will go back into my Visual Studio Code. You'll see I now have that images folder and this SVG file here. It doesn't have to be in your project folder, it's just here so I can inspect it in detail. So if I actually click on this file, you can see that, so this is that image. So the way that image gets exported is by a series of HTML elements with the SVG tag and groups, and a lot of math and numbers here, essentially defining the shape of all those vectors that I made in these illustrations. So everything from the position, the curves, the colors, everything's embedded within this file here. And you can see what's really neat is that all the HTML elements corresponding to those different shapes that I've created have been assigned an ID with the name of my layer that I specified in Figma. So everything from head, face, eyes, teeth, hair, and so on and so on. And why is that so important? Well, it's because really once things are assigned an ID with an HTML, we can start access them via JavaScript. So to actually get this SVG file into my site, what I'm actually going to do is just copy all this markup. I'm going to go back to my index.html file, and I'm just going to paste it directly into the body here. So if I grab that and paste it, hit save. If I go back to my file here and hit refresh, you can see that SVG file is now embedded. And this is vector format, so we don't have to worry about resolution or it being scaled or getting pixelated on different devices. It is just there. Again, if I inspect this, I can see that that is just the actual HTML element. I can actually inspect the different elements based on the layers in my Figma file with their relevant IDs. Everything is here. So let's, now that we have this illustration in here, let's actually write some JavaScript to start interacting with it. Okay, so I'm going to look at my HTML file here, and I've got a few different elements I can interact with based on ID. So I'm going to come into my JavaScript here. And again, similarly, first thing I want to do is define some variables for me to actually interact with these objects. So I'm going to do something like, say, start with my hair. And again, I'm going to get this element by ID. It's called hair. I'm going to separate this from the work I've done above just by adding a comment. So if you do 2 slashes here, you can create a comment. Do a slash and an asterisk, you can comment out large or multiple lines of code. But just so I can stay organized, I'm going to do that. So I'm going to, similar to just getting my div element, I'm going to get this SVG hair element. I am now going to use that object, add an event listener. And here, I'm going to stick with the mouse enter event. And I'm going to define a function. So actually, I should probably have defined that first. So I'll leave that blank for now. But what do I want to happen when the mouse enters here? So I'm going to say a function. And I think what I want to do is actually, I'm going to define a function that's called, I will say this on highlight. And again, this time I'm going to say my hair dot class list dot add, and I'm going to add a class. I'm going to call this highlight. So here, to describe what I want to happen is that I want, when my mouse enters the hair object, essentially, I'm going to call this function called onHighlight, and this function is going to add a class to my element, my hair, called highlight. But I need to define what that class is. So I'm going to go over to my style document, create a new class called highlight. This can be done before or after. And I want to think about, well, what kind of visual treatment would I want? So if someone mouses over this part of my illustration, I want it to highlight. So something I'm going to do, I can't just change the color. Color would just change the text. But for these shape objects, I'm actually going to change the fill attribute. And this is going to change the fill color. I want to bring that preview back. Let's find a nice highlight that's going to provide nice contrast with everything else. Let's go with fuchsia. That kind of stands out. And again, you can just put a hex value if you want. I'm going to hit save. And let me double check everything again. So in my HTML, I've got a object called hair, which corresponds to my hair layer in my SVG file. I've got a class called highlight, which changes the fill attribute to fuchsia, and I've got a function which adds that class when a mouse enters that hair object. So let's hit save. Let's go back. Let's refresh. Let's see what happens here. As you can see, as my mouse goes over that hair, it gets highlighted. But one of the problems here is that it doesn't get unhighlighted when I mouse out of it. So let's go back and let's write some more code. So again, I can do what I did above. I can write a new function. I can say, I should probably name these a lot better. I'll call this exit highlight. And maybe just so I can stay organized, I'll call this on enter highlight. I will change that. And I can just copy this. But rather than adding the highlighted class, I'm going to remove the highlighted class. And let's save that. Come back to my file, refresh, and you can see, oh, nothing happens. And of course nothing happens, because if I go back to my code here, I defined that function, but nothing is actually calling that function. I've just defined the logic on what it means for on-exit highlight to occur, but I forgot to add my event listener. So I'm going to say my hair, add event listener, and this time I need to listen for the mouse leaving, and when the mouse leaves the object, I'm going to call my on-exit highlight. I hit save, come back, refresh, hope for the best. Yes, so I mouse in, and we can see the class changes, and it highlights. I mouse out, the class gets removed. And again, so if I go in here and I inspect it, it's a little tricky to see in the SVG here. If I find my hair, somewhere in this code, we're getting a class added. There we go. So you can see the fill by default, the fill attribute is here. By default, it's set to this value, which is this kind of tealish green. There's no class assigned to it just yet, but when I hover over it, I add the highlight class. When I hover out of it, it removes that class. Okay, so we've written some JavaScript to help us highlight certain elements, like change the class of it so we can respond to user input. Now, say I wanted to do this for other parts of my SVG file. Well, one way to do that is I could kind of go through this, the other parts of my SVG file and grab their ID. So let's see, next thing is face. I know how to get my element. And I could do something like, add my event listeners. Rather than adding them to the hair, I can add them to the face object and the face object. But if we look at this, and look at this logic, we're adding an event listener, and then we're saying that, when we enter the face, mouse enter, call this function our highlight function, but our highlight function is specifying our hair object here. So if I was to save this, come back here, refresh, you can see now the hair gets highlighted if I hover over the face or the hair. That's probably not exactly what I want. So I guess if I'm looking at this, one way to do this is for every single event listener I'm adding, for every single object I need to interact with, I guess I could write separate highlight functions and for every single one of those. But that's pretty cumbersome. I think I've got like half a dozen objects I might be able to interact with in that SVG. And really, I'm just doing the same thing again and again to each one of these things. And so here's where the power of functions really starts to become apparent. So rather than having to kind of rewrite the same functions again and again and again, which are doing the same thing, we can change them so that they're a little easier to repurpose. And I think here's one of our first kind of JavaScript isms we're going to introduce here, is that when we define these functions for these JavaScript events, like mouse leave and mouse enter, there's actually a hidden parameter that we can't see here, where when these functions are called, they kind of remember which object was uh, triggering them, often known as what the event target is. So even though we don't see it here, uh, there is a parameter or an argument being passed. It's often denoted just with the letter E. So what I'm going to do here is um, specify a argument or parameter, I should say, E on my functions. And rather than calling a specific variable pointing to a specific element, I'm going to say take that E parameter and call the target on it. And what that's doing is saying that, hey, whatever is calling this function, there's some element that's triggering this function that's being called. Let's pass that element itself to the function, and then we can then add this class list or access the class list of whatever that element may be, and then add our classes appropriately. So rather than having to rewrite functions again and again and again, we can make them a little more generic so we can repurpose them, and it saves us a lot of time from rewriting the same code over and over again. So I'm going to save this. Okay, so I will set my target to and change the class list, and everything else stays the same. I'm adding the class and removing the class. So now rather than specifying the specific element, I'm just going to target a generic element that is going to be passed as an argument to my functions when the event listener is triggered. So I come back to my page and refresh it. If I hover over the hair, in and out, it still works. So it's specifying the hair element is now calling that highlight function and adding and removing the class as needed. If I go over the face, you can see the same thing is happening here. So now I have that one function, two different objects, each with the similar event listeners calling the same functions. Okay, so now let's start extending this and putting some of the other pieces together. So I've got the ability to roll over and inspect certain parts of my HTML site. So what I can do is extend these functions to provide a bit more functionality. So highlighting is nice. We're calling out parts of an illustration. I've got this label component that I've made earlier. All it's really doing is giving cheesy Star Wars quotes right now. So what if I extend these functions to actually update those labels and let users know what they're actually highlighting over. So what I'm going to do is come down into the functions I've created, and right now all I'm doing is saying, whatever element is triggering this function, add my highlight class to it. But I've already got my label object defined up here, right? I got it, assign it to a variable called myLabel, and I already know how to update the content of that label. So let's use some of that functionality we've already built. So I'm going to say myLabel.textContent equals, and now maybe I want the actual name of that element to appear in the label. So again, I don't want to write separate functions every single time I want to show the name of one of these objects. It's really just the same functionality again and again, right? So roll over an object, highlight it, and now I want to just show its name. So I can again use this target field of my event. So my event I've just called E. I can call it anything I want. I'm going to say target, and now I'm going to get the ID of it. So now I'm saying when this function gets called by my rollover event, highlight it, but also change the text of that label. So let's see what happens when I refresh. Now you can see if I roll over the hair, it says hair. If I roll over the face, it says face, and switches back and forth. When I roll off, it still says face. So maybe I want to change that. So I can come here and now edit this. I can say my label dot text content equals, and maybe I just want it to be blank. Just say nothing when we're not rolling over a label. So I'm just going to pass an empty string there. Let's refresh it. And you can see it's working now. Hair, face, so on and so on. So it looks like that removes the text, but I've still got that whole element sitting there. And I don't really like that. So let's try something else instead. So what I could do is start using this other ability I have about being able to add classes and remove them. So maybe I'm going to come over here and I'm going to create a new class called hidden. I'm just going to set the opacity to 0. So make something invisible. Come back to my JavaScript, and let's do this. So when we, instead of just removing that, we're going to say my label, access the class list dot add. So we're going to add that hidden class to it. Let's see what happens. Refresh it. Now I mouse over, it disappears. Problem is, it's not coming back. So now we need to have a similar call when we actually call that highlight function. So I'm going to say my label dot class list, and this time I'm going to make sure I remove that hidden class if it's there. Let's try this again. Refresh it. Label's there. There you go. So now you can see if I'm hovering over something, I get a label. When I'm not, it disappears. So if I was building this experience right now, it probably doesn't make sense to have the label appear by default. So what I can do is come back to my script, and maybe right way back at the beginning here, I think I'm going to get rid of some of this other code that I was working with. So I'm going to do a slash asterisk and then asterisk slash to block off all this code. And right away, when I get this label, I think something I'm going to do is, rather than wait for an event or a function, I'm just going to go ahead and add that hidden class by default. Now, when I go back to my page and I refresh it, you can see that label is gone. Actually, you see a little bit of a flash for a second. And then everything else works as normal. So this is how I can put it all together. To build a bit of interactivity in the site, show modals on specific events, whether they're clicks, whether they're hovers, and a lot of it's based on kind of very basic functionality around adding and removing classes to change the style, and updating the content of actual HTML elements themselves, whether that's the text. So a lot of this is really just building on the things we would manually be doing when we're creating sites in pure HTML and CSS. We are just moving some of those manual processes into a script and into functions that get executed on certain events as a user interacting with the DOM. Great. So feel free to play around with this file. I am going to take this finished document and publish it into our class Bitbucket site, which will be under a final. And actually, I still have to do that. So let me actually do that right now. Perfect. So I just push that code. If I refresh here, in the final branch, you'll see all the files that we just made. So our index file is here, including the SVG file that we added. Let me make this a bit smaller. Along with the JavaScript that we wrote, and the CSS document we generated with the classes we created. So again, if you'd like to try this yourself, you can jump right to the final files and play around with it. If you'd like to follow around this tutorial, go back to the beginning of this video, pull the start branch, and you'll be able to follow along with me, and then you can compare to what I have in the final branch here. If you'd like to see, if you run into any errors or yours isn't behaving exactly the way mine's behaving. So this is our first intro to JavaScript. We talked about the components of object-oriented programming, and some of the concepts like encapsulation are behind that. We dug into building our demo, where we talked about how to interact or interface with the DOM itself, and how we can use event listeners and functions to trigger visual changes based on user input. So in the next series in this tutorial, we'll be looking at building off these principles, again, sort of changing or providing feedback to users, changing the visual look and the feel of our websites based on events that are happening. But we're going to start looking at more complex events like scrolling events when we make storytelling sites, providing more complex types of feedback besides just highlighting and labeling, like being able to trigger CSS animations and even play an actual like flipbook style animation back and forth. So stay tuned for those videos, and feel free to pull those project files and play with them yourself.